Okay, so ionic compounds then. I'm going to look at sodium chloride and talk about how ions can be formed and then how we can actually form ionic bonding. So what we have is a sodium atom here, which has an electron configuration of 281. That tells us that there's 2 electrons on the first shell, 8 electrons on the second shell, and 1 electron on that outermost shell. So we know that there is 1 electron, so this is a way of determining that sodium is in group 1. When we look at the chlorine atom, what we can see is it has 2 electrons, then 8, and then 7. So we know that chlorine is in group 7. So we have a metal and we have a non-metal. Now, sodium, because it's in group 1, if it loses an electron, it will end up with a full outer shell on the second shell. Therefore, it has a more stable electron configuration. So we show sodium as being a positively charged ion because it has lost 1 electron. Now the chlorine actually gained that electron, so instead of it having 7 on its outer shell, it now has 8. So if we looked at the number of protons inside the nucleus compared to the number of electrons, there is 1 extra electron compared to the number of protons. So therefore the chlorine ion has got a negative charge. So we now have 2 ions which are oppositely charged. And what will happen is with these oppositely charged ions, they are going to be attracted to each other. So what we have to understand is this attraction is actually called the strong electrostatic forces of attractions, which act in all direction, is called the ionic bonding. So we have ionic bonds between our oppositely charged ions. Now, as I said here, these strong electrostatic forces of attraction, which pull these ions together, actually act in all directions. So therefore, that means there could be chloride and sodium ions all directions if there is enough of them. So therefore what we end up with is ionic bonding results in a giant structure or a giant lattice, but we tend to just describe it as sodium chloride, NaCl, and we show that with its empirical formula, but you have to remember that it's a giant structure and these ionic bonds are working in all the different directions. So what we end up with then is this giant lattice. Now, this giant lattice, if I think about my salt is a solid. So it's a solid because it takes a lot of energy to break up this giant ionic lattice. And therefore, because it takes a lot of energy, they have a really high melting point. Remember, melting is where we're going to change that state from a solid state to a liquid state. And it also has a very high boiling point. So that would be changing its state from the liquid to the gaseous state. So we have to understand that these ionic bonds are strong electrostatic forces. Now, once we have actually melted our ionic compound down into the molten form, which is the molten ionic compound, those ions are now free to move around. Therefore, they can conduct electricity. And we can see that if we were trying to put 2 electrodes into a molten ionic compound, a liquid state of the ionic compound, what would happen is the chloride ion, because it's negatively charged, would be attracted to the positive electrode, and the positive ion of sodium would be attracted to the negative electrodes. So it's important that we understand how this movement of these ions, when they're free to move, that allows for this conduction of electricity. Now, well, what happens if we were to dissolve an ionic compound in water? Now, this one's really interesting because you actually have to understand a little bit about water. Now, water has a partial charge to it. If you go on to study A-level biology or A-level chemistry, you'll learn more about these dipole interactions. But what you have to understand is that water has a partial charge where the hydrogen sides are more positively charged and the oxygen side is more negatively charged. So what happens then is when I take my sodium chloride and I dissolve it in water, the sodium and the chloride ions are actually going to be separated. That is because there are interactions with the water and the ions, and those interactions are strong enough to break the ionic bonds. And what then happens is water actually surrounds the ions, forming a hydration shield, and this actually stops the ions coming back together again, and that is how we can dissolve our ionic compound in water. Now, what happens when we dissolve our ionic compound in water? We have now got our ions which are free to move within the solution. So because we have broken the ionic bonding, those ions are now dissolved in the solution. They can move around. That therefore means that if we have a solution of ionic compounds, it can also conduct electricity because those ions are free to move, and they will therefore go to the oppositely charged electrodes, which will be dipped in the solution. So I hope you found this useful, and I will keep making more. So keep liking and keep subscribing.